Hello everyone, this is Manali Jain and this video is part of CMPE281 Personal Project. Here I am demonstrating MongoDB Sharding. This is the architecture of our MongoDB Sharding where we have 3 config servers, 2 shard servers, that is the 2 shard datasets, shard 1 and shard 2, a MongoDB query router which is a proxy for all our read-write and queries. It is an interface between application and the shard servers. For implementing this architecture, I have set up 3 config servers, 2 shard datasets, and a Mongo query router as a AWS EC2 public instances. I have created that from an AMI. That's an Ubuntu AMI which already has MongoDB installed on them. So now I'm using this config servers and shard servers to actually implement the architecture. Here you can see I've already logged SSH into these servers. This is my config server. I've already initiated replication on them. So in here one will be primary and the other two will be secondary. Also here one will be primary and the two are secondary for the shard clusters. So here you can see that our config replica has primary and 2 secondary. Similarly shard has primary and 2 secondary, and the shard 2 already has primary and 2 secondary. Now here is our Mongo's query router. From here we will do read and write. It will collect the metadata from the config servers and decide on which shard to send them. So first of all we'll start, and also the configuration for each of the clusters, config servers, query router, and how to initiate replication on them, that is the sharding server. Everything is written in this markdown file. It can be followed from here. Now we are move to our sharding steps. So first of all, for demonstrating sharding, I'm using the BIOS database and I'm using a CMPE281 DB. So I've already done use CMPE281 DB, and now we'll create a BIOS collection inside it. Before inserting the BIOS collection, we need to decide on a shard key on the basis of which our data will be shard. So I have decided to go on with the hash shard key because it helps in evenly distribution of our data. For that, I have decided our object ID to get is a shard key, because if we see our BIOS collection, we have name, contrib, awards, birth and death as a key, and all of these keys are not in all of our documents. Some of them doesn't have awards and birth, so awards, contribs, births are opted out from our shard keys. The name is left, which is common for all the documents, but we cannot use it because what if our documents have names starting with A? So all the documents will go into one shard cluster, and that's not evenly distributed. So I have decided to go with object key, which will help in evenly distribution of our data. So I have already done use CMPE281 DB and I have enabled sharding on the same DB. Next we are going to insert a highest object ID on our BIOS collection, and then we are going to shard our BIOS collection based on that object ID. The next thing is to insert some data into it. So I'm inserting 2 data in our BIOS collection. Inserted in second. It's inserted. To see the status of our shard cluster, we'll use this command to see whether, this one, to get the shard distribution. You can see that for our shard 2 cluster we have one chunk, that is one document, and our shard 1 we have the other document. If we insert one more document, it will go into any of the shard clusters, which will demonstrate that we are having evenly distribution of our data. We can insert few more BIOS collection into, here are the 10 records, and we'll see that the data is evenly distributed into shard 1 and shard 2. I'll insert few more and the screenshot will be attached in my project inside the screenshot folder. One more thing I want to tell is the security groups for my config and shard server is 22 for my SSH and 270.172.19. So 19 is used for the config servers and 17 for the Mongo servers. And this all I have created from an AMI which I have created by myself. For which have Ubuntu, which is an Ubuntu EC2 instance, and already have a MongoDB installed in it. After that, it was much easier to create 9 clusters, 10 from the already existing AMI. Now I have inserted 10 records in my BIOS collection, and we can see here that the shard distribution is getting distributed in both the shards. So here I'm using CMPE 281 DB. If you see that my BIOS has a count of 10 documents, and if I do db.bios get shard distribution, you can see that at shard 1 there is 5 documents, and at shard 2 there is 5 chunks of data, there is 5 documents. So our data is getting evenly distributed. I'm going to demonstrate my wow factor in the personal project. So for the wow factor in my personal project, I'm using Amazon EKS, that is the Elastic Cloud Service for Kubernetes provided by Amazon. And I'm going to demonstrate a NoSQL data replication in a NoSQL database, like inserting data, deleting data from it. So here I'm using Redis as a NoSQL database. This Amazon EKS, the steps to create Amazon EKS. So I have referred this from the Amazon official documentation. It is described how to create role, how to create a cluster, how to run the AWS CLI and stuff. So we are gonna go through it quickly. So Amazon EKS can be integrated with the Elastic Load Balancer, IAM, and VPC to help us configure the EKS. We are first describing a rule that Kubernetes can assume to create the AWS resources. So for this role, you can go into Amazon console and you can create a role over here. So I have already created a EKS service role, and I have provided 2 policies on it, that is the admin policy and service policy. Here are the steps to create the policies for that role, which will help to provide access, that is we can restrict the calls getting to our cluster with these policies. Second thing we need to do is to attach these policies to our role. So in this way you can do that. Now the next thing, we'll create a group to attach to a user. So first of all, we have created a user like this before for a Cloud9 user in IAM. So similarly, we'll create a new user over here, that is the AWS EKS user, and we'll attach this user with some groups. So then here you can see that I have attached Amazon few of the policies to the group, that is Amazon EKS cluster policy, worker node policy, service policy. This admin and password policy are the 2 that we created earlier. So this group can be attached to a user. The user creation is very simple. You can see that here is the user that I have created. We'll use this user for logging into our clusters and accessing the services to it. The next thing we are going to do is create a VPC. So we must create a VPC and security group for our cluster, which by this we can achieve network isolation. So here are the steps where you can create a VPC. For VPC, you need to go to the CloudFormation. Here you can see and create a stack. So I have created CMPE281 EKS VPC. With this VPC, you can see I have some security groups, VPC ID, and the subnets attached to it. We will use this information later. After this, we are going to install AWS IAM authentication for EKS. Why we need this? Because Kubernetes has kubectl to communicate with our cluster. In the same way, Amazon EKS cluster will require AWS IAM authenticator for Kubernetes to allow the IAM authentication for the Kubernetes cluster. So for this, we are going to download the binary from AWS, and then we are going to perform these operations on it. So here you can see that I have a VPC created and the binary is being downloaded. The next step after this is to install AWS CLI. This will help us to configure the IAM credentials for us, that is for the user. So to install it, we'll use brew and then configure the AWS. Our user will have an access ID and access key. We'll provide this, and then we'll create a cluster in our AWS CLI with this command. So here you can see that I have given the role, the subnet ID, the security group. This all I get while I was creating the cluster, the VPC cluster. So here you can see I have created the EKS cluster. These are the configuration, and we can check the status that it's been active now. It will take a few time to get active, few minutes to get active. So now the VPC cluster is done, the AKS cluster is done. Next we are going to do is configure kubectl. So these are the simple steps which we'll use to configure kubectl. And then last but not the least step is to have EKS worker nodes. These worker nodes are the Amazon EC2 instances. So we'll create worker nodes. Here you can see that I have created a worker node. These are the worker nodes. So how we'll create is by having I'm giving the cluster name because the worker node will be associated with this cluster name. The stack name is, you can give any stack name. The auto scaling group minimum size 1 to 3. Instance type is T2 small. This is how we create a basic EC2 instance. So worker node will behave the same way. One more thing to keep in mind is AWS EKS is only available in few regions, that is Virginia and Oregon. So we are doing everything in Oregon, so we need to create a PEM file for it, which will attach with our worker node. So we'll follow these few steps and our worker node will be ready. So now we have done every configuration setup for our EKS cluster, Kubernetes cluster. The next thing we are going to do is to have a guestbook application running on it. This guestbook application is given by Amazon, so we can follow that tutorial. Here we have deployed Redis. We have deployed a Redis master and slave configuration. These are the terminal commands we can use for it. And now we are going to do some replication testing on Redis. So now our kubectl and everything worker nodes are up and running. You can see that I have 3 worker nodes being created over here. So what I'm going to do is to get all the pods that is being running. So this command will help me get the pods. So these are the pods that I'm getting. I have a master and 2 slave, and I have some guestbooks, controller and services running. So these are basically an application which is for tutorial purposes. So what we are going to do is to execute the shell for Redis. So I'm going to execute it. Here you can see that I'm going into the shell for master. So we are in the shell of master, and now here I'll do Redis command line. The next thing we are going to do is to insert some data. So let's say the key for me is Five Guys, and the value is, let's say, how many restaurants, stores of Five Guys are there in California. So that's 20. I'm setting it. That's been done. Second, again I'm setting burger. So that's being done. Here I am going to log into the secondary node, sorry, the slave node, and again into the slave node. Here Redis CLI. You can see that if I do get Five Guys, you can see, okay, data is being returned. Here get 5, you can see the data is there, so the data is getting replicated. Now let's just delete some data here. So I'm gonna delete Five Guys. Let's see whether data is consistent or not. Data is consistent because I deleted the key, and now if we are getting the key, we're not getting it. So in this way, Redis is working fine on AWS EKS. So that's all for the wow factor.